All right, so this is Monday, November 28th. So today's lesson is strictly a review on solving systems. So we are going to first start by solving with graphing. So I want to remind you that when you want to solve a system, a linear system, by graphing, the first thing that you want to do is put each equation into slope-intercept form, and that's your y equals m times x plus b. So your first equation is already written in slope-intercept form. So this is the equation y equals 2x minus 5. So let's identify the slope and the y-intercept from y equals 2x minus 5. Well, remember that your slope is represented by the letter m, and it is attached to the x variable when it has been solved for y. So my slope is 2, and I try to write my slope as a fraction, 2 over 1, because that means I'm going to go up 2 and to the right 1. My y-intercept is the constant at the end. So my y-intercept is negative 5, and this tells us where we begin on the y-axis. So I'm going to go ahead and graph that equation, negative 1, 2, 3, 4, 5. And then I'm going to go up 2 over 1, up 2 over 1. And I'm going to do this as long as the graph allows me, because I want to make sure I have a nice straight line and that I'm going to get a nice exact intersection point. Okay. So our second equation is the equation x plus 3y equals 27. We need to solve this. We need to solve this in terms of y. So the first thing that I'm going to do is I'm going to subtract x from both sides. So now I have 3y equals negative x plus 27. I'm trying to get y all by itself, so I need to divide every single term by 3. That gives me y equals, there's a 1 right here, so negative 1/3 x plus 9. So my slope in this equation is negative 1/3. That means I'm going to go down 1 and to the right 3 after I graph the y-intercept, which is at positive 9. So let's graph positive 9 on the y-axis, and then I'm going to go down 1 over 1, 2, 3, down 1 over 1, 2, 3, down 1 over 1, 2, 3, and I see that I have crossed the other line, and their point of intersection, it kind of turned green, and I'm going to put a yellow highlight on that. So this point of intersection is the ordered pair 1, 2, 3, 4, 5, 6 on the x-coordinate, 1, 2, 3, 4, 5, 6, 7 on the y-coordinate. So 6, 7. So now it says check your answer. Well, remember, if you're going to do the check, you take the ordered pair and you plug that in for x and y into both equations. So the first equation, y, which is 7, equals 2 times x, which is 6, minus 5. Does 7 equal 12 minus 5? Does 7 equal, let's see, 12 minus 5 is 7. Yes. So the ordered pair 6, 7 works for the first equation. Let's check the ordered pair 6, 7 for the second equation, which is x, 6, plus 3y, 3 times 7 equals 27. So that gives me 6 plus 3 times 7 is 21. And 6 plus 21 is 27. So this works. All right, let's do another example. So same thing, our example here, the first equation is written in slope-intercept form. So I'm going to begin at negative 5. That's my y-intercept, and I'm going to go up 1 over 2, and I'm going to continue that until I have a nice set of points that is going to allow me to draw a nice straight line. The second equation, I have to solve for y. The second equation, I have to solve for y. So I'm going to add x to both sides. That gives me 2y equals x plus 4. Then I'm going to divide every term by 2. So y equals 1/2 x plus 2. My slope is 1/2. My y-intercept is 2. So I'm going to begin at positive 2, go up 1, over 2, up 1, over 2. Hopefully you see that these equations have the same slope. And we learned that if two lines have the same slope but different y-intercepts, that means that they are parallel, which means they will never intersect, which means you have no solution. All right, let's see. We have one more example for graphing. So this first equation, we need to solve for y. So do you remember what form this equation is written in? Hopefully you do. This is point slope form. So the first thing I need to do is distribute that -3 through the parenthesis. -3 times x is -3x. -3 times -1 is +3. Then I'm going to subtract 7 from both sides. So y equals -3x. 3 minus 7 is -4. The second equation, I am going to solve for y as well. 3x plus y equals -4. I will subtract 3x from both sides. That gives me y equals -3x minus 4. Now, I'm not even going to graph these two equations because you see that these end up being the same line. You're going to have two lines right on top of each other, right? This means that you have infinitely many solutions. Okay. All right. So now I want to review solving a system using substitution. So we are going to use substitution. This was your least favorite method. So in my first example, I see that y equals x plus 1 and y equals 2x minus 1. Well, since x plus 1 is equal to y, I'm going to replace the y in the second equation with x plus 1. So I'm rewriting the second equation. Instead of using y, I'm writing x plus 1 equals 2x minus 1. Now I'm going to get all my x's on one side. So that gives me 1 equals x minus 1. And then I'm going to move my constants all to the same side. So 2 equals x. So in this system, 2 is the x coordinate for my solution. I need to find the y coordinate. And remember, in order to do that, I just take one of the original equations and I plug back in the solution for x. So y equals, x is 2, so 2 plus 1, y equals 3. Okay, you can do the check very quickly on this. Remember, if you're going to check, you just plug it back in to the original equations. 3 equals 2 plus 1, 3 equals 3. That works. And for the second equation, 3 equals 2 times 2 minus 1. 3 equals 4 minus 1. 3 equals 3. So we have solved this system using substitution. Our second system, again, using substitution, but notice that I see that y equals 2x. So I'm going to replace that right here in the second equation where I see the y. So 7x minus y equals 15. But again, remember, I'm replacing the y with 2x. So 7x minus 2x equals 15. Well, 7 minus 2 is 5. So I have 5x equals 15. Divide both sides by 5. That gives me x equals 3. I'm going to take that, x equals 3, and plug it into the first equation. y equals 2 times x, which means y equals 2 times 3, or y equals 6. So my solution is the ordered pair 3, 6. For my next example, I want to solve one of these equations for for either x equals or y equals. So remember the steps to this was you want to look at each coefficient attached to the variable, and you want to see if you have a variable that has no coefficient, like this right here. So we're going to solve this second equation for y. We're going to make this say y equals. So I have negative 6x plus y equals negative 7. I'm going to add 6x to both sides because remember I'm trying to get y all by itself. So y equals 6x minus 7. And now I'm going to take this expression, 6x minus 7, and plug it into the first equation in place of the y. So the first equation is 3y plus 7x equals 4. But I know that y is the same thing as 6x minus 7 plus 7x equals 4. And now I need to distribute. 3 times 6x is 18x. 3 times negative 7 is negative 21. Plus 7x equals 4. Let's see, 18 plus 7 is 25x. Minus 21 equals 4. I'm going to add 21 to both sides. Sorry, that was my brain working faster than my hand. So 25x equals 25, which means that x equals 1. So remember, you take that solution and you have to plug it into one of the original equations. 3y plus 7 times 1 equals 4. 3y equals 7, plus 7 equals 4. When I subtract 7 from both sides, I have 3y equals negative 3, which means y equals negative 1. So my solution is the ordered pair 1, negative 1. All right, for example number 4, there is no y in this equation, so this is probably going to be the easiest one to solve. So I'm going to rewrite x minus 2 equals 0 and solve for x. So I add 2 to both sides. X equals 2. So that's the x coordinate of my ordered pair. And I'm going to take that and plug it right into the top of the first equation. So instead of x, I'm going to use the number 2. Minus 3y equals 14. Subtract 2 from both sides. Negative 3y equals 12. Divide both sides by 3. And you find out that y equals negative 4. So that is an example, 4 examples actually, of solving using substitution. Excuse me. Okay, so now we're going to solve using elimination. Remember, the key to using elimination is you want to have the same coefficients on your x's or your y's, but they need to be opposites. So if I were to try to get rid of the x's, if I wanted to eliminate the x's in this first system, I would need to multiply my top equation by 3. So I'm going to do that. Remember, when you do that, you multiply every single term. So 3 times x is 3x, plus 3 times y is 3y, equals 2 times 3, which is 6. And then I didn't do anything to the second equation, so I'm just going to stack it right below here. Negative 3x plus 4y equals 15. And again, I want to eliminate a variable. When I add these together, I eliminate the x's. 3x minus 3x is 0. 3y plus 4y is 7y, and 6 plus 15 is 21. Divide both sides by 7, and you find out that y equals 3. So my y coordinate of my ordered pair is 3. Now I'm going to take that solution and plug it back into one of the originals. So x plus y equals 2. Remember that y is 3, so I have x plus 3 equals 2. Subtract 3 from both sides, and x equals negative 1. For my example number 2, I'm going to multiply the top equation by a positive 4. That will again allow me to eliminate my x's. Remember, I'm multiplying every term. 4 times x is 4x. 4 times 5y is 20y. And 4 times 17 is 68. And then the second equation, we're not doing anything to change that, so we're just going to stack it right below. And again, we're going to add these two equations together. Positive 4x and a negative 4x become 0x, so that cancels out. 20y plus 3y is 23y. And 68 plus 24 is 82. So 6, 7, 8 is 92. Sorry, that's 92. Okay. So I'm going to divide both sides by 23. And I find out that y equals 4. So I don't know what x is, but I know that y is 4. I'm going to take that and plug it into my first equation. X plus 5y equals 17. Remember that y is 4, so x plus 5 times 4 equals 17. Well, that gives me x plus 20 equals 17. I will subtract 20 from both sides, and I find out that x equals negative 3. All right. For example number 3, I'm going to try and get rid of the y's just to change it up a little bit. So I'm going to multiply the top equation by a positive 3 and the bottom equation by a negative 5. So let's see. 3 times 2x is 6x. 3 times 5 is 15. 15y equals 3 times 11 is 33. Equation number 2, negative 5 times 4 is negative 20x. Negative 5 times 3 is negative 15y. Negative 5 times 1 is negative 5. Again, I'm still going to add these two equations together. So a positive 6 and a negative 20 equal a negative 14x. Positive 15y, negative 15y, these cancel out. 33 minus 5 is 28. Divide both sides by negative 14, and I find out that x equals negative 2. Now I need to take that and plug that back into one of the original equations. I'm going to plug it into the first one. So 2, instead of using x, times negative 2, plus 5y equals 1. Well, 2 times negative 2 is negative 4, plus 5y equals 1. I am going to add 4 to both sides. So 5y equals 5. Divide both sides by 5, and I determine that y equals 1. All right. For number 4, I'm going to multiply the top equation by negative 2, and that will allow me to cancel out my x's. Negative 2 times 3 is negative 6x. Negative 2 times 4 is negative 8y. Negative 2 times 29 is negative 58. Right below it, the 6x plus 5y equals 43. Add my equations together. My x's cancel out. Negative 8 and a positive 5 give me a negative 3y. Negative 58 and a positive 43 give me 15, negative 15. Divide both sides by negative 3, and I find out that y equals 5. I'm going to take the fact that y equals 5 and plug it into my first equation. So 3x plus 4 times 5 equals 29. 3x plus 20 equals 29. Subtract 20 from both sides. 3x equals 9. Divide by 3, and I find out that x equals 3. So that's your examples for elimination. So your homework for today, you are going to complete page 3. You have 3 examples where you graph using, you solve the system using graphing. And then you have 1, 2, 3, 4 that you solve using substitution. And 1, 2, 3, 4 that you solve using elimination. And that is your homework. You need to do the checks. You need to check 2 with substitution, and I want to see it. And then you need to check 2 from the elimination. So pick 2 out of the 4 that you solved in this area using substitution and check 2 of them. So 2 out of these 4, and then 2 out of the 4 that you solved using elimination. Okay, that's due on Tuesday, and I will see you on Tuesday. Thank you.